Okay, let's look at number 27 on page 287, section 4.3, where we want to be graphing functions. This one is a trigonometric function, which makes them a little bit trickier. So I decided I'd do this one. And now the thing is, we're only also looking for it when theta is greater than or equal to 0, less than or equal to 2 pi. So we're not looking for all infinities, just over a certain region. Where are the zeros? You know, what are the important points of this graph so we can graph it pretty easily without using Desmos or something. And we should use Desmos to check, but we're going to try to make a nice graph of this thing just by using calculus and not just plotting points, plugging in theta equals 0.1, 0.2, 0.3, 0.4, 0.4, and just putting dots, right? We're going to try to do it by finding all the interesting points, which are called critical numbers. Okay, typically first thing you want to do is take the derivative, figure what the slope is doing. So f prime of theta, derivative cosine is negative sine, so that's negative 2 sine theta. Derivative cosine is negative sine, so that makes that positive sine of 2 theta. Since we have a 2 theta in here, we got to take the derivative of what's inside. Derivative of 2 theta is 2, so times 2. And so that's our derivative. So one thing we want to know is when is it positive and when is it negative. And one way to help figuring that out is when is it 0. So typically the first thing you always want to do is set that equal to 0 and figure out where the slope is 0. And then we know it's going to be positive or negative on either side. So that's always the first step. Okay, so let's put the negative 1 over there. So that's on this side we have 2 sine of 2 theta. That's 2 sine 2, that's a positive 1, equals, put the negative over there, so it equals 2 sine of theta. And clearly the 2's cancel out. So the slope is 0 when sine of 2 theta is equal to sine theta. But we want to know what theta is. And this is kind of a mess. Sine of 2 theta, like what do you do with this? And you don't do anything with this except change it. So what we can use is a trig ID. And so be comfortable with looking, you know, just look them up online, or if you have that thing I have you, but the thing I think I gave you a trig ID sheet. But anyway, online has everything. Sine of 2 theta turns out is the same as 2 sine theta cosine theta. Okay, you can just look up these trig IDs. So we can replace our sine of 2 theta with this. That makes it work really nice. So now we have 2 sine theta cosine theta equals sine of theta. Okay, well clearly we can divide both sides by sine of theta. However, before we do that, sine of theta can be 0. Right? And we don't want to divide by 0. So, and if sine of theta is 0, we have 0 on both sides. So one solution is when sine of theta equals 0. Now, when does sine of theta equal 0? So let's draw our graph here, our unit circle. Sine is the y value. So sine is how high above the axis. So sine of theta is equal to 0 here and here. So that's 0, 2 pi, 4 pi, you know, going on forever. And also at pi, 3 pi. Now the only ones that we're interested in, because we're limited to, right, we're limited to 0 and 2 pi. So we have 0, 2 pi, and pi. So the places where it's 0, where this works, is theta is equal to 0, pi, and 2 pi. So those are some of the places where the slope is 0. Okay, so right here we have 3 places where the slope is 0, but there could be more places. Now let's divide by sine theta when sine theta is not 0. So those cancel out. We divide both sides by sine theta. This becomes a 1, right? Divided by sine theta on both sides. Divided by sine theta, those cancel. So this happens when 2 cosine theta is equal to 1, or when cosine theta is equal to 1/2. So we already have 3 places where the slope is 0, in between 0 and 2 pi, and we might have more. The other places are when cosine theta is equal to 1/2. So when does cosine theta equal to 1/2? Now cosine theta again is the x value. So 1/2 is right here. So let's see, yeah, so cosine theta is equal to 1/2. That means that the how far across here, right? The x value is 1/2, so here's 1/2, so it's going to be like right here and right here. So there are two places where this happens. One of them looks like it's maybe, I don't know, 60 degrees or something, and then negative 60 degrees, or that could be all the way around to this place too. So let's figure that out. So theta then is the inverse cosine of 1/2, and if you plug that into your calculator, you will find that this is something you should know. So when does cosine theta equal 1/2? And that's at 60 degrees, which is pi over, let's see, pi is 180, so pi divided by 3. And if we did that in our calculator, so 0.5 cosine, if you do it in degrees, you get 60 degrees. So which is better to write it as pi, because that's what we're interested in. We want radians, so that would be pi over 3. 60 degrees is pi over 3. Now, your calculator only spits out one number. We know there's two. It's right here and right here. And if this is pi over 3, this is 2 pi minus pi over 3, right? So we go all the way around the circle to 2 pi, minus 2 pi over 3. Minus pi over 3. So this number there is pi over 3, and then also 2 pi minus pi over 3 is the other one. That's why it really helps to draw the unit circle. I mean, I do it every single time. It's not that hard to draw it and figure this out. Let's see, that would be, 2 pi, that would be, let's just do that out. So 2 pi minus pi over 3, we want to make that thirds, that'd be 6 pi over 3, right? That's 2 pi minus pi over 3, which should be 5 pi over 3. We'll just leave it like that. So we have 5 places where the slope is 0. So let me just write that out clearly. The slope is 0, or the derivative is 0, at theta equals 0. Let's write them in order. Pi over 3, pi, and then 5 pi over 3, and 2 pi. 5 places in our interval where the slope is going to be 0. This crazy function. Okay, that's interesting. Now, what is the slope on either side of these? Are these minimum, maximums? What's going on? Inflection points? Are they this kind of thing? So where it's not a minimum or a maximum. So to figure that out, we got to know the second derivative. So let's figure out the second derivative. So I'm going to rewrite. I was hoping my voice would hold out. It's terrible. Okay, first derivative. I'm going to rewrite it here. So the first derivative from above was, let's see, 2. I'm going to write it this way. 2 sine of 2 theta. It's always nice to put the positive one first. Minus 2 sine of theta. This is a very easy second derivative. So let's take the second derivative. I keep writing my theta first for my parentheses. They're both kind of curvy like that. Okay, derivative of sine is cosine. When we do the chain rule, we're going to get derivative of 2 theta is 2, so I'm going to get a 2 out of it, so it's going to make that a 4, right? 2 times 2 is 4, so it's going to be 4 cosine of 2 theta. And this one's easy, minus 2 cosine theta. Derivative of sine is positive cosine, so it just goes like that. Okay, that's the second derivative. Now, inflection points, where it switches over, where the slope switches over from positive to negative, is when this is 0. Okay, so one thing we want to do, I'm going to keep this in a box here because we're going to look at that. So one thing that's nice to know is where it's 0. And then on one side it's going to be positive, one side it's going to be negative. So it's nice to find the zeros of the second derivative too. So let's figure out those zeros. So 4 cosine of 2 theta is 0 when, well, I'll just set that equal to 0, show all my work. So minus 2 cosine theta is equal to 0. Put the 2 over there. So we have 4 cosine of 2 theta is equal to 2 cosine theta. Put the 4 over there. Well, divide both sides by 2, so I have 2 cosine 2 theta is equal to cosine theta. So those are going to be the places where the second derivative is 0, which means that they're going to be inflection points, because where it switches over from being positive to negative. Okay, so just like before, we're going to have to find a trig ID for cosine of 2 theta. So there are a bunch to choose from. It looks like, and this is where it's just trial and error here. So I'm going to choose the one where it's just 2 cosine squared theta minus 1. So cosine of 2 theta, it's not going to be quite as nice as it was before, is 2 cosine squared theta minus 1. 2 cosine squared theta minus 1. I'm just looking online because I have it open. So this is 2 times 2 cosine squared theta minus 1 equals cosine theta. Let's see, multiplying that out. 4 cosine squared theta minus 2 equals cosine theta. Okay. Let's see, how can we simplify this? Let's put we want to solve for cosine theta. So let's put everything in the same side now. So we have 4 cosine squared theta minus cosine theta minus 2 equals 0. Well, this is looking like a quadratic formula, right? We have a squared by itself and a minus 2 equals 0. So we can use a quadratic formula to solve for cosine of theta, which is kind of cool. So let me get a new sheet of paper out. Like I said, these take a lot of paper. Hopefully I have some extra paper at home. Okay, so first you make sure I did this right, because if I made a mistake it'd be a real bummer. So 2 cosine squared theta minus 1 is cosine 2 theta. That's right. So then I multiplied it by 4 minus 2. Put that over here. Yep, I think I did this right. Okay, so we have that cosine theta is equal to negative b. So a is 4, b is negative 1, like, because this is negative 1 there, and c is negative 2. So negative b is 1, plus or minus the square root of b squared, which is just negative 1 squared, which is 1, b squared minus 4a, which is 4, and c, which is negative 2. All divided by 2a, all divided by 8. Well, this isn't so bad. That's equal to 1/8, I'm just divided by 8 right now, plus or minus the square root of, let's see, that makes it plus 4 times 2, let's see, 16, 32, square root of 33 over 8. Oh, that's not a pretty number. Make sure I did this right. 1 minus is 1 plus, so 4 times 4 is 8. 4 times 4 is 16, times 2 is 32, plus 1 is negative, plus 1. Yeah, that must be right, square root of 33 over 8. Okay, that's going to be an ugly place. Let me just decimalize that. I was hoping it'd be a pretty number, but it's just not going to be a pretty number. So, it's 33 square root plus 1 divided by 8. Okay, if I do the plus, it's 0.843. And if I do the minus, I get, so, I get negative 0.593, or negative 0.593. That's what cosine of theta is equal to, right? Cosine of theta is equal to those things, when the second derivative is 0. So what is theta? So theta then is the inverse cosine of 0.843. And if I do that one, an inverse cosine, so oh, and you want to have your calculator in radians for this, which mine is not. There we go. Okay, so inverse cosine of 0.843, I get 0.5679, let's take 0.568, 0.568, and the other one, inverse cosine of negative 0.593 equals 0.593 negative second cosine 2.2055. Let's say 2.206, 2.206, and these are in radians. Okay, these are in radians. So let's draw our unit circle, because make sure you didn't forget something. Okay, so at points, cosine of theta is equal to 0.843. So here 0.843 is like, this is 1, so maybe like right there. There's two possibilities. There's this one, which is 0.568, and then there's also this one. So there's two possibilities, and again, using our calculators only get one. So at 0.843, there's 0.568, but there's also this one, which again, like before, it's 2 pi minus 0.568. So the other solution is 2 pi minus 0.568. Remember, 0.568 is radians, so that's, you know, a decent angle there. Okay, the other one is when cosine of theta is negative 0.593. So the x value is about point, so right here, right? So there's two answers there. There's this one, which is what it gave us, which is 2.206, which is a little bit less than pi, right? Pi is 3.14, it should be here. Here's pi, so right there, which makes sense. But there's the other one down here, which it didn't give us. This one is pi. Okay, there's different. How do we figure out this one? So again, it would be, this one is 2.206. This one is 2 pi minus that amount. Right here, it's the positive amount. Here, it's the minus amount. So it would be 2 pi minus 2.206. There's different ways to figure out that angle. You know, you can go from here and go how much more it is from pi, but I think that's the easiest. Is 2 pi, the full circle, minus how much we went over, which is the same that we went over here. Those are the two places that the cosine then is going to be equal to those things. So we have 4 inflection points, 4 places where the second derivative is 0, which makes sense because we have 5 places where it's 0. So in between the zeros, it's got to switch over from positive to negative. Okay, so I'm going to do the 2 pi thing. So 2 times pi minus 0.568 is 5.715. That's equal to 5.715. And the other one, 2 times pi minus 2.206 equals 4.077. So this is equal to 4.077. So those are our inflection points where it switches over from positive to negative. Okay, now I think we're ready to draw our graph. Well, except, okay, we also need to know where is the second derivative positive and where is it negative. And all we got to know is one point, because we know where it switches over, which are these places. So let's figure that out. So let's see, we know it's 0 again. I'm going to rewrite my zeros in this new piece of paper. The slope is 0 at 0 pi over 3, pi, 5 pi over 3, and 2 pi. That's where the slope is 0. And we know that we have inflection points at these places up here. So always in between. So 0, then we have a 0.568, and then we have pi, and then we have something in between each one of these as inflection points. So actually, let's write that in. So 0, the next one is 0.568. So 0.568 fits in there. And then between pi over 3 and pi, that's the 2.206. And then between pi and 5 pi over 3, that's the 4.077. 0.077, and then between those two is 5.715. 2 pi 6.28, so yeah, that makes sense. So these are the places where it switches over from concave up to concave down. So if we draw this, we know that we only go from 0 to 2 pi, so I don't even need to put all that stuff over there. So we go from 0 to 2 pi, so let's put a 2 pi here. And I'm going to make it bigger because we don't need to go, I shouldn't have drawn this, it doesn't matter, I'll just make it bigger this way because I can. I'll put 2 pi way the heck over here. Okay, so let's see, here's pi, this is a long video. Here's pi divided by 3, so pi over 3. Here's 5 pi over 3. Break this up into thirds, so 5 pi over 3, and 2 pi and 0. Okay, those are all the places the slope is 0, and in between. Now, at 0, the slope is 0. So let's see what this function is at 0, because that will be easy. So our function is f of theta. We're going to want to plot points. We want to find a few points so we know what's going on. What are the points where these are? 2 sine theta minus cosine of 2 theta. So at 0, cosine of 0 is 1. So cosine of 0 is 1. So we have 2 minus 1, so it's 1. So let's put a 1 right here. So at 0, it's 1. Now let's do another easy one. Let's do pi over 3. Cosine of pi over 3 is 1/2. So at pi over 3, we have 2 times 1/2, that's 1. And here we have cosine of 2 pi over 3. And so what's that? That's double the angle, so that would be 2 times pi divided by 3 and cosine. And it's negative 1/2. So 1 minus negative 1/2 is 1 plus 1/2. So that would be 3/2. So it actually goes up here. So at pi over 3, it's 1.5 or 3/2, so it goes up here. Let's do this next interesting point. What is it at pi? That's the next place it's 0. So here, these are the places where it's 0. So it's 0 here and 0 there. Actually, do we even need to do that? Well, we should to get the perfect answer. But look, how can it possibly be 0 here and 0 here? The only way is if this is a minimum and that's a maximum, right? That's the only possible way. It's got to look like this. Let's do what pi is, because that's pretty easy. Cosine of pi is negative 1, so that's negative 2, minus cosine of 2 pi is 1, so minus 1, so that's negative 3. Ooh, goes up even higher. So then it goes up to pi to negative 3 way up here. So that is a maximum there. Let's see. So we had a minimum, maximum, and that means, should I do something wrong here? See, cosine of pi is negative 1, so it's negative 2, minus cosine of 2 pi, which is 1. So negative 2 minus 1 is negative 3. So negative 3, okay, negative 3 is way down here. I knew I did something wrong in my graph. So negative 3, I was thinking positive 3. This goes to negative 3, so it's way down here. Negative 3, so then at pi it's like negative 3, so which makes sense. If there's a maximum, it's got to go to a minimum. And at in between at 0.568 there's an inflection point. So actually here 0.568 somewhere in here there's an inflection point. At 2.206, which is somewhere in here, and here's where it gets weird, right? We have pi's. Where is 2.206? I don't know, but this is a minimum. So then it goes back up again, and somewhere in there is the inflection point. Let's say that's 2.206 is the inflection point where it switches over. So see, here it's concave down between inflection points. Here it's concave up right to there. because that's an inflection point. That's why the inflection points are important to graph, so you know where it's concave up and concave down in between inflection points. So from here to here it's concave up, switches over at this inflection point at 0.568. This is 0.568 right there, roughly. And then now it's concave down all the way to here, and then it switches to concave up to the next one. Let's see. We need to know now 5 pi over 3. Plug in 5 pi over 3 to cosine theta. So 5 times pi divided by 3 equals that. So cosine is a half. So that would be 2. And 2 times 5 pi over 3, so it would be 10 pi. And that would be cosine is negative 1/2. So this would be at 5 pi over 3, this is 1/2. So 2 times 1/2 is 1. Minus, I got negative 1/2 here, so minus negative 1/2 would be 1.5. So it goes up to 1.5 next at 5 pi over 3, which is right about here. And then at 2 pi, what happens? Cosine of 2 pi is 1, so that would be 2 minus cosine of 4 pi, which is also 1, so it would be 0. So it looks like it's actually 0. Wait, did I do that right? Cosine of 2 pi is 1, that would be 2, minus cosine 4 pi minus 1. Oh, so it would be 2 minus 1, which is 1. So at 2 pi it's 1, so it goes up to here. So this is what our graph looks like then. It goes up to here and then goes down to 1 where it's also 0 and switches over. Somewhere in here there must be inflection point. Somewhere in here must be inflection point. 4.077 would be this one. 4.077, and then this one would be about 5. This last inflection point, 5.715, 5.715. So between here it's a concave up to right here, concave down, and then concave up again. This is a 0 slope, and it probably goes up here. So here it's concave up in between those places. Okay, now clearly if you draw the graph, you can also say where it's increasing. We know it's increasing from here to here. It has to be if you draw the graph. We don't need to plug in all our numbers. You can immediately say where it's increasing. From 0 to pi over 3 it's increasing. From pi over 3 to pi it's decreasing. From pi to 5 pi over 3 it's increasing. From 5 pi over 3 to 2 pi it's decreasing. So by drawing this graph, the increasing decreasing part is really easy. Okay, this has been a long problem. Holy cow, this is my longest video ever. Hope you stayed with me. These problems are long. The trigonometric ones, are tricky. You got to really take some time on it. Use a lot of paper, a whole lot of pies, drawing unit circles. That's just the way it is. Try to draw as careful a graph as you can. Then check it on Desmos to see if you got it pretty much right. Again, these problems take a long time, but that's just the way it is. They're good exercises. They're certainly good trigonometric practice. So hope you could follow that. Again, I suggest you try it on your own. Drawing the unit circle is essential to get all the different points, and then plugging in things really carefully. I wasn't as careful as I should have been, but I think I got it right after catching myself, because I can, kind of knew what I was supposed to get or what would make sense. So, okay, tricky stuff. Bye.